Okay, I've got one last example for you with, oops, okay. One last example for you where we've got an infinite discontinuity in the interval of integration. So I wanted to handle this one though without having the graph in front of us of the integrand there. Just to reiterate that you don't really need to know detailed information about the graph of 1 over the square root of x minus 3 to set this thing up as a limit. So what you need to notice is that there's a non-removable discontinuity in this function here when x equals 3. So that's going to be an infinite discontinuity. So if we're trying to integrate from 3 to 4, but we know we've got this infinite discontinuity at 3, that means that we're going to set this thing up with a limit as t approaches 3. Let me set this up. So limit as t approaches 3. And this time we're approaching 3 through values slightly bigger than 3. We don't do anything with t values less than 3. So we're only approaching 3 from the right. And we make this the integral from t to 4. Okay. So that's the first major step, is to take your improper integral and express it as a limit. And the t here, that t is kind of wandering off. Let me be clear that this t, I'm going to rewrite it, is the lower limit of integration. It's not part of the integrand. It was kind of wandering over there closer to the integrand. Okay, that's better. Now, next order of business is find the antiderivative of 1 over x minus 3 with respect to x. So I'm going to do that scratch work off to the side over here, I think. So if we're integrating 1 over the square root of x minus 3, we can integrate that with a u substitution where u equals x minus 3, in which case du is just equal to dx. And so this thing has the form the integral of u to the negative 1/2, since it's a square root in the denominator, du, because dx is equal to du. And so using the power rule, when you add 1 to that exponent, you have u to the positive 1/2. So we could put that over 1/2, or we could just multiply by the reciprocal, which is 2. Let's see. So coming back over here, then this is equal to the limit as t approaches 3 from the right of, now we've got an antiderivative, 2 times u to the 1/2, which is the square root of u, x minus 3, which I probably should have written over here. Okay, as x goes from t to 4. Now, when you substitute your finite value here, I don't need to write the limit in front of that. So 2 times the square root of 4 minus 3. Nothing in that depends on t, so it doesn't care about t approaching 3 from the right. So I'm not going to write the limit in front of that portion here. Just 2 times the square root of 4 minus 3. Minus, okay, so now we're going to substitute t, so that's where the limit will matter. So I'll write the limit here. Limit as t approaches 3 from the right of 2 times the square root of t minus 3. Okay, so this is 2 times, so the 4 minus 3 is 1, square root of 1 is 1. Okay, so here, 3 is in the domain of this function, so we can just substitute 3, and we have the square root of 0, which is 0, so 2 times 0 here. And you just substitute. And so overall, this is just equal to 2. Since we have a finite value here, then the integral converges. And more precisely, we can say that the integral from 3 to 4 of 1 over the square root of x minus 3, which is an improper integral because of the infinite discontinuity at 3. But we know now, and I'm writing with my finger, so forgive me, it's going to be hard to write small. converges to 2.